Welcome to average rate of change on an indefinite interval, hard mode. We're going to compute the average rate of change on an indefinite interval from x to x plus h for this function, x cubed plus 7x, and it's going to be messy, so buckle up. I know that I'm going to use the same thing, my final minus initial over final minus initial, so it's going to be something minus something over final minus initial. Well, final is x plus h, minus initial is x. So this top part, this will be g of x plus h. This will be g of x. And so now I just need to plug those things in. Well, g of x plus h is going to be x plus h to the third power plus 7 times x plus h. And this will just be the function itself. It's already defined, g of x. X cubed plus 7x. Rewriting on the next line. I'm going to do this expansion in my head. If you don't remember how to do a binomial raised to a third power in your head, pause here. Use the FOIL method or whatever you prefer, and just do it to make sure that you get the same answer that I do. I can do this in my head, so I'm going to jump right into it. It's x cubed plus 3x squared h plus 3x h squared plus h cubed plus, distribute that 7, I get 7x plus 7h, and then minus x cubed plus 7x is just the same as minus x cubed minus 7x. I'm essentially distributing the imaginary negative 1 that's out in front of that all over x plus h minus x. This is where something special happens. I get really excited about it. The first component had a positive x cubed, and the second component had a negative x cubed. The first component had a positive 7x, and the last component had a negative 7x. And the denominator had a positive x and a negative x. So these two eliminate each other. This eliminates that, and this eliminates that, which means that what's left, 3x squared h plus 3x h squared plus h cubed plus 7h all over h. And the same thing that had me excited last time has me excited again, because every single term has an h, which means I can factor it and cancel it. So factored version of this looks something like this. Pull an h out of this first term, I'm left with 3x squared. Pull an h out of the second term, I'm left with, pull an h, 3x h. Pull an h out of the third term, I'm left with h squared. And pull an h out of this last term, I'm left with plus 7. And all that is over h, which means I have achieved my goal of factoring so that I could cancel. Then, rewriting, this becomes 3x squared plus 3x h plus h squared plus 7. And that will be my average rate of change between any 2 points, x and x plus h, where h represents the distance between